All right, so in this video, we want to determine how to calculate the time of flight for a body, projected at an angle theta to the horizontal. Actually, the Suvat equation can be used, but there is a standard formula one can use without having to use the Suvat equation. So the first thing is, what is the time of flight? The time of flight of a projectile basically is the time taken for the projectile, you know, from the point of projection to the landing point. How do I mean? So let's assume that a projectile is projected from this point. I call this one the what? Point of projection. Point of projection. And this point is where it's landed. So I call this what? Landing point. So the time of flight basically is the time it takes you to travel and comes here. And it's another way we can calculate the time of flight is we can actually multiply the time it takes to reach the maximum height by 2, because the time it takes to reach the maximum height is basically the same time it will take it to land if air resistance is not considered. So when a projectile returns to the plane from which it was projected, its vertical displacement is equal to 0. Let me use something. For example, when this projectile travels like this, the vertical displacement is somewhere like this. Let's say it corresponds to this particular height. So when it returns back, it's just like it goes up and also return back. So it goes like it covers this vertical displacement and it also return back within the same vertical displacement. So let's say the vertical displacement upward is, let's say, positive and the vertical displacement downward is negative. So once it return back, is what is net displacement, being a vector quantity, will be equal to 0. So what does that imply? It implies that when a projectile return to the point from where it was projected, the vertical displacement h will be equal to 0. All right, so that one is very important because we need it, because when it landed here, it has returned to the point of projection. So we are going to be using one of the Suvat equations. So we are going to be using what S is equal to what ut plus what half what at square. And don't forget, since the body is projected vertically upward, then we can transform this particular equation to what bh is equal to what u subscript yt, right, minus what half gt square. So like I said earlier on, when the projectile return to the same level from which it was projected, the vertical displacement h is equal to 0, because that is the only condition that will make us to know the time of flight. Time of flight can only be calculated when it has returned. So in this case, it has returned to the landing point as we have it here. All right, so in that case, h is equal to what? 0. So we can say that 0 is equal to what? U subscript yt minus what half what gt square. So let me bring this in. So I can say that half gt square is equal to what u subscript y t, right? So t cancel t because this is t square, so we can say that gt over 2 is equal to what u subscript y. And don't forget that u subscript y is what u sine theta. So if we cross multiply, I have what gt is equal to what 2 u subscript y, which is the same thing as saying 2u sine theta basically. So t will now be equal to what 2u sine theta over what g. That's we divide through by the coefficient of t, which is what g. But most time, because we have what we call time taken to reach the maximum height, so we normally distinguish it from the time of flight. So in this case, we take t to be equal to t, which is what time of flight. Okay, so we can write the time of flight as what t is equal to what 2u sine theta over what g. So before I conclude this video, we can also determine the time taken to reach the maximum height. Now let me come back to this diagram I drew here. So let's say a projectile is fired at an angle theta to the horizontal, and when it is going, of course, it is reducing in velocity because gravity is pulling it down. When it gets to this point, this is, let's take this as the maximum height, which is what, h, right? The time it takes to get to this point, right, is also equal to the time it takes from this point to reach the landing point, all right, if air resistance is neglected. So with that understanding, we can determine the time taken to reach the maximum height by dividing the time it takes for the whole journey by 2. And the times for the whole journey is the what? The time of flight. So this will now lead us to time taken to reach the maximum height. So what will now be the time? Now let me scroll up. Taken to reach the maximum. So we can say that time taken to what? To reach maximum what? Maximum height. Time taken to reach the maximum height. So I will use small t in this case. T will now be what? Capital T, which is time of flight divided by 2. So we can say that will be what? Time of what? Of flight. Time of flight divided by 2. And don't forget, we already have our time of flight here, which is 2u sine theta over g. So we can say that t is equal to what? 2u sine theta, right, over g, right, divided by what? 2. So this one will turn to what? 2u sine theta over g times 1 over 2, because if you turn division to multiplication, this will invert, because this is basically 2 over 1. So these two cancel what? These two. So at the end of it, our time taken to reach the maximum height will now be what? T, which is equal to what? U what? Sine what? Theta over what? G, where T is what? Time taken, okay, to reach the what? The maximum what? The maximum height. So I believe this video has helped someone. Please don't forget to subscribe to this channel, like the video, and share with your friend. And if you have any comment concerning the production, please kindly drop in the comment section. We'll be looking forward to receiving it. So see you in the next video. Bye.